Hello. So now let's talk about acid, bases, and salts. So this lesson is on what are acids, what are bases, and three of the reactions that you will learn out of the five, which technically some parts of them you may have heard of it from the lower sec. Okay, so what happens when you think of the word acid? What is an acid? So when you think of acid, you think of things that are sour. You think of things like what? Seeds, fruits. So all these are true. So you'll learn exactly what it means by acids. So you find acids that they are present in our daily life. For example, we marinate meat, or we can add like using lemon juice. So look at this. There are some common acids here. So what is the thing they have in common? We can see they all have H+. So okay, the definition here is not ideal. I want a definition here. Definition. Acid dissociate or ionize in water to produce H+ ions. So a few parts, I must have water. No water, it is not going to behave like an acid. Next thing, it dissociate or ionize. So dissociate means it essentially break apart. Do not write the word dissolve. Cannot write dissolve. Cannot dissolve. No. It's dissociate. So it separates essentially. And the third thing is you must have H+ ions. Yep. So this is the 1 mark definition that they will almost always test in O-level. Yep. So some physical properties, acids have a sour taste. Acids, hey, you see, it can conduct electricity. Why? Because by definition, it dissociates in water to form H+ ions. So the acid dissociate in water to give you ions, and these mobile ions will allow it to conduct. So it's a definition that tells you so. It turns blue litmus paper red, which is something we have done before, lower side. Yep. Okay, next one, reactions. So there are 5 reactions in this topic, and they are quite key in the whole O-level syllabus. First reaction is here, acid plus metal give you salt plus hydrogen. To me, this has a name to it. We call it displacement. Okay, don't panic. What is displacement? You think of the word displace, you think of the word replace. I mean, it sounds similar, and you're not wrong. But here, the idea is a more reactive element kick up the less reactive ion and takes its place. So that's the idea. So acid metal gives you salt plus hydrogen. So you see the word here, they use the word reactive metal. How am I supposed to know what's reactive metal? So you will actually learn the reactivity series, but which we will touch on later on. If I'm not wrong, it's 2 or 3 topics later. But for now, you can just say that all the metals all metals so far except your silver, gold, copper, which are basically all coins. Silver coin, gold coin, copper coin, basically coins. So what's a salt? Your salt essentially is just a cation and an anion. A metal and a non-metal, essentially lah. Yep, so the first reaction, so actually all the reaction gives you a salt. So acid metal gives you a salt plus hydrogen. So what is this? So more reactive. So more reactive element in this case is like magnesium. So magnesium on its own, like a more reactive, like a guy who go gym a lot, like very buff guy. He goes in and see that H is paired with SO4. H that is like a normal doesn't a scrawny guy. So this buff guy come in and kick the scrawny guy out and steal the girlfriend. Something like that. So the more reactive element kick out the less reactive. Then now the less reactive is all by myself lah. So something like that. Just kick and replace. Yep. Second reaction is called neutralization. So it's acid plus base. Why? Because acid is acidic, base is alkali. Acid, alkali together give you pH 7, neutral. So neutralization. So acid plus base give you salt plus water. Because water is neutral. Yay. So that's two reactions already. And the third reaction is here. Acid plus carbonate gives you salt plus water plus CO2. This is your third reaction. So these three reactions are quite key. Okay, next segment you have your strong acids versus weak acids. So what's a strong acid? A strong acid, right, is essentially telling you that. So why is strong acid, weak acid? So strong acid, weak acid is basically you are essentially born with it. Or in the word here, the inherent properties. So if you are strong acid, you are strong acid. That's it. Nothing you do will change it, essentially. So the definition here would be, so just now we learned the acid definition, right? So acid definition. So we extend it a bit. So you look at the keywords here. The keywords here is this word, completely and partially. So strong acid, dissociate. You can choose either way, either word, dissociate or ionize in water to produce high concentration of H+. Weak acid on the other hand, so ionize completely. So this is 100% because everything. Whereas what about weak acid? Weak acid, everything is the same here, just that tiny changes. Dissociate or ionize partially in water to produce a low concentration of H+. Okay, so it basically not 100%. But for those who are very math inclined, right? What exactly are we talking about? We are talking about, so the strongest of a weak acid, so weak acid, the strongest of the weak acid, it only dissociate 1%. So cannot fight, really cannot fight. Very big difference. Yep. So there's a definition. One is 100% dissociation, one is just not 100%. And you must remember, H plus AQ ions, these are important ions because they are responsible for the acidic properties. So it's very key. Yep. Strong, okay. Next one. Strength and concentration are different terms. So if you are strong acid, you are strong acid. That's it. If you are weak acid, you are weak acid. That's it. That doesn't change. So you realize that I intentionally don't like to use the word stronger acid, weaker acid, because there's many things that can change to tweak the answers. So the word I use here is strong. You are strong. You are weak. That's it. Quite absolute terms. Yep. Next one will be, what is a base? What is a base? So actually you'll find a lot of bases in a lot of your cleaning products at home. Yeah. So a base is actually very generic. A base is just any metal oxide, any metal hydroxide. Very generic. These are bases. Bases are very generic. Then there will also be another term known as the word alkali. Alkali are soluble bases. So this one only got a few of them. You have your sodium hydroxide, potassium hydroxide. So if you look at your periodic table, right? You remember your periodic table? The one that you're supposed to give me to laminate. So let's take a look at the periodic table. Where's my periodic table? So you look at the periodic table, you see this particular table. Okay, let me copy this over so that it's in your slides, it's easier to see. It will be somewhere here. So this is the solubility table that you're supposed to memorize. Meaning with this, right, I can tell you any salt, you can tell me what's the state symbol. That means whether it can dissolve, it cannot dissolve. So in your textbook, you only have the nitrate. The textbook only got these three. Textbook only got these three. But I tell you, the fifth one is to make your life easier also. This is actually basically your base. Base and alkali. That means any group 1 hydroxide is soluble. For example, let's say my question now is lithium hydroxide. Hey, group 1. So this is your group 1. Then your OH minus is your here. So we consider this soluble, so it is AQ. What if it's zinc hydroxide? You realize zinc is not group 1 and none of the above. So with that, you realize that this is actually insoluble. So all bases are bases, obviously, but all alkali are bases too. Because alkali means soluble base. Means you must first and foremost be a base. Yep. So this table is supposed to memorize, but because you have your periodic table for now, you can do memorize first because it's quite lengthy lah. It's hard to memorize. And what are the properties then? So bases, you think of base, right? You might think of soap lah. Sometimes or toothpaste. Wow, it's so bitter. Not entirely wrong. So bases have bitter taste, and bases feel slippery and soapy. So if you recall in the lab when you're doing titration, maybe one of the chemical accidentally touch your hand, then you feel that how come my hand now very soapy, very slippery? That is very likely the alkali that you come across. So actually they are slippery and soapy. they can conduct electricity. And why? Remember, okay, we learned about acid definition, right? But I never say anything about alkali definition, because they are actually the same thing. If acid dissociate to give you H plus, then alkali dissociate to give you OH minus. Yep, they turn litmus paper blue. Yes. There's a reaction here. So acid alkali, actually this is essentially just acid plus base, essentially, if you realize. So it's nothing new. Nothing new. The new reaction here, this is your fourth reaction that you'll be learning. So alkali plus ammonium salt. Ammonium salt means it can be anything, but as long as you have an NH4 plus. It could be ammonium nitrate, ammonium chloride, ammonium carbonate, whatsoever. Again, salt plus water plus ammonia. Yep. So we covered 4 reactions so far already. Yes, next one we'll talk about relative acidity and alkalinity. So how do we do this? So if you are I don't know whether you are aware, but actually a lot of the indicator, how they work is that when they are too acidic or too alkali, they will have a particular color. And when they are so-called, we use them correctly at the middle point, it should look them good. Okay, so let's take a look. So you see this, all these are the colors that we are involved with. Then you might be wondering, why these 4? Because these 3 are what we use in titration. So I mentioned before, in the lab, if you don't remember the color, you can always take a random acid and you really can figure out the color. Yeah, but theory-wise, if you forget, then a bit hard lah. So yes, so this is what happens. Our titration is all 3 of them, if you realize, if you recall. Right? Yep. Okay, do take note, indicator don't react. They are just there to like change color as necessary. I guess like a living chameleon or something. So you have here your indicator, color of universal indicator. That's cool. So these are just some of the common things that we come across perhaps. Yep. So you realize that if it's a universal indicator, pH 7 is green. pH 0 to 2 is red. 3 to 6 is orange or yellow. pH 13, 14, purple. Yep. Then after that, your 8 onwards are all alkali. So what is this pH thing, right? So what happens is this when your pH is less than 7, it means that you have essentially your H plus concentration of H plus is more than the concentration of OH minus. So it's acidic lah. You have H plus lying around. Then same thing on the other end. This is hopping around. Yep. So pH meters. Interesting. So they are just electronic devices that allow us to monitor the pH very accurately over time. Yeah, with that actually we are more or less done for the slides. But I will show you using your homework, your acid bases worksheet 1. I will show you how to do some of the questions so you can try. Okay, so let's take a look. Okay, I'll go through question 6. So, it says hydrogen chloride gas. Isn't that just HCl? Once you see HCl, right, what comes to our mind is, HCl acid lah. Be careful, it already say it's a gas. And you're dissolving in this weird metabenzene thing. But the key thing is, this is not water. So if there is no water, so there is no H plus AQ. So there's zero acidic property. So it means that there is no acidic property. So if there is no water, it cannot dissociate or it cannot break apart, right? What does it tell you? Should you have ions then? So all the ions segment out. So then, okay, so it's either hydrogen chloride molecule or hydrogen and chlorine. Of course, it's C. Yep. So because it's not just one HCl, many HCl all combined together. That's the idea. Yep. Okay, question 10. Okay, a type of reaction, right? So if you recall, first and foremost, you have acid definition, right? And then we find a new page. So first, your acid dissociate, ionizes in water, yep, so it dissociate. Then you will have what we call a strong acid. Dissociate or ionize. So one extra word lah, fully in water to produce H plus. That is strong, which means there is also a weak acid lah. Weak acid dissociate ionized food partially in water to produce a high concentration. This is to produce a low concentration of H plus. So that's acid. Then have you wondered? Then alkali, same. So the alkali definition is it dissociate / ionize in water, still water, to produce OH minus ion. So that's at the counterpart. So if there's alkali, there's also definitely going to be acid, strong alkali, weak alkali. So it's a similar idea there. Yep. Reactions. Number 1, acid plus base gives you salt plus water. So this is often what I call neutralization. Yep. Second reaction is called acid plus metal. You get salt plus H2. It's called displacement. But remember the analogy? Something about the more reactive element, the kicking out the less reactive and take its place. Third step, a third reaction, acid plus carbonate. Salt plus CO2 plus H2O. No name already, huh? Fourth one, alkali plus ammonium salt. You get salt plus water plus NH3. So that is the fourth reaction. And of course, you also need your solubility table to help you figure out the state symbol especially. Let me find the thing. Where's the table? Let's take a look. Yep. Yep, so these are just a quick reminder of what is being taught. So now, do you want you to write equation? Sure. So, read lor. They say what? Sodium hydroxide, which is sodium is group 1, Na plus, hydroxide OH minus. NaOH. Okay, so it's NaOH. So, look at the thing. Is it soluble or not? It is. You can see for yourself here. Hydroxide, hydroxide, group 1, soluble. So this is AQ. Yep. Plus hydrochloric acid is HCl. So you don't know the salt is okay. At least write down the other things that we know. We know that we have water, which is liquid. Then after you ask yourself, what here on the left hand side haven't appeared on the right hand side yet. Can see the difference one. Right? So we can see that Na plus have not appeared, Cl minus has not appeared. When they cross method, you get Na1 Cl1, which is NaCl. So NaCl AQ. Yep, and after that you balance it last. In this case, it happened to be balanced. Do you recall ionic equation? I thought I taught that before. So all the aqueous ionic compound can split to its individual ions. Because ionic compound aqueous or molten, they are free to move about. So NaOH, you have Na plus OH minus AQ plus H plus yep, give you H2O liquid. Liquid means you can't touch it. Na plus AQ plus Cl minus AQ. Then you can see for yourself, some things here looks exactly the same. Na plus, Na plus. Cl minus, Cl minus. So your actual answer here is just H plus plus OH minus yeah. Okay, next one. Name two apparatus that can be accurately measure the volume. Well, we just did this titration 3 times. So they are your burette and pipette lah. Yeah, so that's it lah. They are very smart. It's true. Yep. Okay, and the last one I'll go through is example of the reaction, how to write. So hydrochloric acid, right, if you recall, is H plus and Cl minus. So they are HClAQ. Plus calcium. Calcium is on its own. Calcium is a solid. So if you realize this acid plus metal. So acid plus metal gives you salt and water, right? Salt and H2. So you write down H2. You see what have not done. Then some of them will tell you that, oh, you need to do your worksheets. I'm like, oh, yep. Okay lah, it's like this Yep. So acid plus metal, give me salt. I don't know my salt plus CO2 plus H2O. Sorry, my mistake. So this is displacement, right? So you will get a salt and H2. So what's the salt here? See for yourself. Salt plus H2. You can see that Cr minus is missing. Ca also missing. So if it's 2 plus minus, you get CaCl 2Aq. Balance it. Balanced. Yep. That is for 12 part 1. So you can try the remaining of the questions. Then after that you hand in on Monday to me. Any questions you can also ask me on WhatsApp. Thank you.